The James Webb Space Telescope has uncovered mysterious lights in space that even NASA can't explain. From unusually bright galaxies to puzzling signals, these discoveries are challenging our understanding of the universe. James Webb amazed scientists by revealing galaxies like Sears 93316, which was formed 300 million years after the Big Bang. Sounds like a long time ago, it's actually quite recent in regards of, our existence. These ancient structures, visible after 13 billion years of light travel, offer a glimpse into the universe's cosmic dawn, right? The early beginning phase, when the first stars began shaping the cosmos. Unexpectedly bright and massive for their time, these galaxies challenge existing theories about early star and galaxy formation. James Webb's infrared vision pierces cosmic dust, revealing details unseen by telescopes like Hubble in the past. This groundbreaking discovery reshapes our understanding of the universe's origins and raises new questions about dark matter, early black holes, and the rapid emergence of galaxies. Number 9. Detailed atmospheres. James Webb has transformed exoplanet research by analyzing distant atmospheres with remarkable precision. Now, it examined WASP 96b, which is a gas giant 1,150 light years away, and it detected water vapor, clouds, and haze, proving its ability to reveal the chemical makeup of far-off worlds. It looks pretty similar to our world here. By capturing starlight passing through a planet's atmosphere during transit and then splitting it into a spectrum, James Webb unveils molecular compositions, climate, and even weather. It's like a weatherman for other planets. That's crazy. How do we see the weather on other planets and we don't know if aliens are real yet? Like, how do we do that? This breakthrough is vital for identifying potentially habitable planets and guiding future missions to explore worlds that might harbor life, of course advancing our understanding of planetary systems. This is ringing interstellar to me. Don't go, Murph, don't go. Number 8. Carbon dioxide detected on an exoplanet. In another groundbreaking moment, James Webb detected carbon dioxide in the atmosphere of WASP 39b, a hot gas giant 700 light years away. This marked the first time ever that this crucial molecule was identified in an exoplanetary atmosphere. Carbon dioxide is an essential marker because its presence can reveal key details about a planet's formation, history, and its chemical processes. For planets closer to Earth-like conditions, carbon dioxide could also be a sign of biological or geological activity. This detection demonstrated James Webb's unmatched sensitivity and precision in analyzing the atmospheres of distant worlds. Even those with challenging conditions, life still may exist. WASP 39b itself is inhospitable to life, but the methods developed here will be crucial in studying smaller, rocky planets in these habitable zones of their stars. So we're not quite there, but we're getting close. Number 7. Glowing cosmic cliffs. James Webb's stunning image of the cosmic cliffs in the Carina Nebula unveiled star-forming regions in unprecedented detail. This photo honestly blows my mind. Located 7,600 light years away, this stellar nursery has been obscured until the telescope's infrared capability then revealed hundreds of hidden stars and structures. And by say hundreds, I mean thousands. There's so many. The cliffs mark the edge of a massive cavity carved by radiation from young, massive stars. Jets of material from forming stars were also captured, offering insights into how stars grow and interact with their environment. This discovery sheds light, pun intended, on the process behind star formation, including the origins of our sun and solar system. Yeah, where do we come from? Where did our star come from? We're getting close. Number 6. Stephan's Quintet, Galaxies in Collision. James Webb observations of Stephan's Quintet, a group of 5 interacting galaxies 290 million light years away, revealed tidal tails, shock waves, and bursts of star formation, all caused by gravitational interactions. The photo is pretty intense. All these galaxies are mixing together. It's almost in action. The telescope also captured how powerful winds from a supermassive black hole, an NG6 7319, affects surrounding gas and dust, offering insights into black holes' role in star formations. Now, these findings help scientists study galactic collisions, key drivers of galaxy evolution, and they hint at the Milky Way's future collision with Andromeda. So we're kind of getting a little teaser trailer for what's coming with our galaxy. Spoiler alert, it's gonna be loud. It's gonna be real hot and real loud. Number 5. Oldest known star clusters. James Webb has identified some of the oldest star clusters ever observed, dating back to nearly the dawn of the universe. That's old. It's older than your mom. Haha. These clusters, these dense groups of stars bound by gravity, provide a window into the early area of star formation, right? This early time, the dawn of the universe, perhaps. Their age suggests that they were formed shortly after the first galaxies, offering clues about the conditions of the early universe. By analyzing these clusters, scientists can refine models of stellar evolution and understand how the first heavy elements like carbon and oxygen were created and then, more importantly, dispersed. These findings are essential for tracing the chemical enrichment of the cosmos, which ultimately led to the formation of planets and life. So this photo right here is the beginning of all of us. Hit that like button. That's the OG right there. Number 4. Organic molecules in the Orion Nebula. James Webb made a groundbreaking discovery in the Orion Nebula by detecting complex organic molecules such as hydrocarbons within this massive star-forming region. Now, these molecules are considered the building blocks of life. You and I, right now, indicating that the conditions necessary for life might be widespread across the galaxy, and not just here on our planet Earth. The Orion Nebula is located just 1,300 light years away, marking it one of the most studied star-forming regions. However, James Webb's infrared capabilities reveal details that have been virtually invisible until right now, such as how these molecules are shielded from harsh radiation from surrounding dust clouds. This discovery supports the theory that life's ingredients are readily available throughout the cosmos. Of course, this increases the likelihood that life exists beyond Earth. Yikes, that's scary. Number 3, water and distant debris disks. Distant debris disks. That's an alliteration. James Webb detected water vapor, believe it or not, in the debris disk of a young star system, offering a brief glimpse into the role of water in planet formation. Now, debris disks are composed of gas, dust, and planetesimals, and they often resemble the early conditions of our own solar system. That's why we study them. The presence of water suggests that such systems could produce habitable worlds. Ugh, this is making me feel sick. This finding underscores the importance of water in creating life-friendly environments and supports the idea that water delivery via comets or asteroids could be a universal process, right? Life is happening everywhere. It's just right here is the only one we got. By studying these disks, scientists gain insight into the factors that contribute to the emergence of habitable planets. Yeah, we see water flying through the sky, we're gonna follow it. Where's that gonna land? Who is that? Number 2, the most precise image of Neptune's rings. This one's cool. James Webb captured the sharpest view of Neptune's faint rings in over 3 decades, alongside intricate details of the planet's atmosphere, which we've never seen before, or at least never like this. This image revealed high-altitude methane ice clouds and a mysterious band circling the planet. Neptune, an ice giant, remains one of the least understood planets in our solar system. So this new data helps scientists unravel its atmospheric dynamics and the composition of its rings. Also, it has rings, which could of course shed light on the process that shaped our outer solar system. This discovery highlights James Webb's ability to revolutionize planetary science, even within our own celestial backyard. We thought we knew it, turns out we don't. Has a ring, all right, it's married. Love that. And finally, number 1, distant galaxies with surprising structures. James Webb uncovered galaxies in the early universe with unexpectedly mature structures, such as these well-defined spiral arms, like these spiral arms, only larger. These findings challenge existing models of galaxy formation, which suggest that galaxies in the early cosmos should appear chaotic and irregular. This discovery raises questions about the role of dark matter and other factors in shaping these massive galaxies. It also suggests that some galaxies formed and evolved faster than we previously thought. Yeah, they're a grower and also a shower. By studying these ancient structures, scientists gain new insights into the process that govern the growth and evolution of galaxies across cosmic time, which of course helps us understand our existence and our solar system and where we came from. Asteroid 2001 F032 passed by Earth in March, you guessed it, 2021. Coming within 1.25 million miles of our planet, sounds far, but it's actually quite close. This is about 5 times the distance between the Earth and the Moon. It sounds like it's a long way to go, but it's actually quite close. Considering this massive asteroid is over 1,300 meters in diameter, it's definitely something scientists want to keep a close eye on. Now, what makes this asteroid especially interesting is that it's part of the Apollo group, which means that its orbit crosses Earth's orbit, and its size makes it a potentially hazardous asteroid. Yeah, potentially, just a bit, just a smidge. James Webb Space Telescope was able to study the asteroid's composition and movement, of course helping scientists understand just how large space rocks behave as they move through the solar system. By tracking asteroids like this, we can learn if they could ever pose a real threat. But for now, keep your distance. Number 9. Comet C 2022 E3. Comet C 2022 E3 made a dazzling appearance in early 2023 as it passed by Earth. For a time, it could even be seen with the naked eye, streaking through the sky as a bright green comet. This was a once-in-a-lifetime opportunity for astronomers, and James Webb Space Telescope, of course, got in on the action. The comet has been traveling through space for thousands of years, and James Webb's powerful instruments gave it a chance to study it up close. Now, this comet, which comes from the outer reaches of our solar system, offers clues about the early solar system and the icy objects that were once common in its farthest corners. Studying comets like this also helps scientists understand the origins of water and organic molecules on Earth, which could have played a role in the emergence of life. Number 8. Near-Earth Asteroid 2021. Asteroid 2021 LJ4 is a relatively small object, all things considered. It's only about 100 meters in diameter, but it passed incredibly close to Earth in June 2021, coming within 2 million miles. Now, while this distance is still quite far in cosmic terms, it is close enough for scientists to take a close look. Using James Webb's powerful sensors, astronomers were able to study this asteroid's composition, surface features, and orbital behavior. By tracking smaller asteroids like 2021 LG4, scientists can gain insight into how common such close encounters are and whether smaller asteroids might still pose a danger to Earth in the future. Even though it wasn't a threat right now, the more we understand about these objects, the better we can prepare for these potential impacts in the future. Yeah, hold on tight. Number 7. Asteroid 2023 BU. Asteroid 2023 BU was another close call. In January 2023, this small asteroid came within 2,200 miles, which is only 3.5 thousand kilometers, right? That was pretty close. That's closer than some of our satellites orbit our planet. Now, despite its small size, around 10 meters wide, this asteroid's near miss made scientists pay close attention. Too close attention. The event sparked a flurry of interest from the global astronomy community, and James Webb's observations allowed astronomers to gather data on its velocity, size, and how it interacts with Earth's gravitational field. While there was no danger, the encounter provided valuable information on how we might detect smaller asteroids before they pass too close. Number 6. Asteroid 2010 CM. Asteroid 2010 CM was a 25-meter wide space rock, and it passed very close to Earth back in, you guessed it, 2010. And while it didn't make headlines this time, its close approach was an important learning moment for scientists. The asteroid's proximity at just 45,000 kilometers from Earth is within the range of some geostationary satellites. Again, this one's really close. James Webb's infrared capabilities allowed scientists to study the object and learn about its composition, texture, and behavior as it came closer and closer to Earth. Obviously, we want to watch it in case it hits us, but it's good to learn some things as well. This observation helped researchers understand the nature of Apollo-type asteroids, and these Apollo-type asteroids are known for having orbits that intersect with Earth's orbit. Even though asteroid 2010 CM didn't cause any harm, it did highlight the importance of tracking these near-Earth objects of all sizes. Number 5. Venus. While Venus itself is not a near-Earth object per se, studying it has been a huge focus for James Webb. Venus is often called Earth's sister planet after all, but its atmosphere is thick with sulfuric acid and carbon dioxide, making it one of the hottest places in the solar system. Venus's proximity to Earth and its extreme weather conditions make it an ideal candidate for study, and James Webb's infrared technology has provided new insights into its atmosphere, and it's pretty jarring. By studying Venus, scientists are learning more about planetary climates, including how climate change might affect Earth over time. That's the main goal. This research is vital for understanding the evolution of planets in our solar system and beyond. Learning about Venus's atmosphere can also teach us how to better protect Earth's delicate environment before it's too late. Number 4. Asteroid 2019 OK caused quite a stir when it passed incredibly close to Earth back in 2019, coming within just 43,000 kilometers closer than the Moon. That's way too close for me. Although this asteroid was only about 100 meters in diameter, its proximity had scientists on high alert because, of course, it's an asteroid. Every time we're going to keep looking. James Webb was able to study its trajectory, size, and composition, adding to the growing understanding of how close asteroids can get to Earth without causing harm. harm. And spoiler alert, they can get pretty close. What made this encounter so interesting was how suddenly it was detected. It came out of nowhere. Astronomers only noticed it a few days before it passed by. So yeah, we almost missed this one. James Webb's advanced technology does help us stay ahead of these potentially hazardous objects by studying them in great detail. 3-day warning? I don't know, it's not enough for me. Number 3, the moon. While not a near-Earth object in the traditional sense, the James Webb Space Telescope has also been used to study the moon. Through its powerful infrared and visible light capabilities, the telescope has captured incredible images of the moon's surface. By studying the moon's surface in more detail than ever before, James Webb is helping us understand how it changed over billions of years. Now, since the moon plays such a crucial role in Earth's history and, of course, future, affecting tides, stabilizing Earth's axis, and even influencing our planet's climate, understanding more about it helps us gain deeper insights about how Earth's environment works. Now, with the moon serving as a stepping stone for missions to Mars and beyond, knowing more about it is key for future exploration. Number 2, asteroid 2022 AE1. In 2022, asteroid 2022 AE1 made a pass near Earth, coming within 4.2 million miles, or 6.8 million kilometers. While this asteroid wasn't considered a direct threat, it provided a perfect opportunity for James Webb to study a space rock on the move. James Webb's precise instruments were able to measure the object's size and composition, helping scientists learn about the characteristics of asteroids in general, which we could always use. Understanding the orbits of these objects and their potential to affect Earth in the future is scary. It's important for developing strategies to prevent any collisions. And finally, number 1, asteroid 1998 OR2. Asteroid 1998 OR2 is one of the larger near-Earth objects, measuring about 1.8 kilometers across. In 2020, it passed by Earth at a relatively safe distance of 3.9 million miles, or 6.3 million kilometers. Now, despite its safe passage, its size, and the fact that it could cross Earth's orbit made it a key target for study. James Webb's observations provided detailed information about how such large objects behave when they approach Earth, how they change where they go, giving scientists critical data about their motion, shape, and structure. This kind of research helps us develop better ways to detect and then hopefully track potentially hazardous asteroids in the future. So far we've been good, nothing's hit us, but who knows. Black holes are one of the universe's most fascinating and mysterious events ever, formed when massive stars collapse under their own gravity. Now, this creates a region with such intense gravitational pull that not even light itself can escape. Stephen Hawking's theory of Hawking radiation suggested that black holes could eventually lose mass and then evaporate. However, if black holes don't dissipate quickly and continue to grow by consuming nearby matter, they could pose a cosmic threat. A large or nearby black hole could potentially tear apart entire solar systems, making their unpredictable nature a significant concern for astrophysicists, and of course, us here on Earth. Number 9. Gamma ray bursts. Gamma ray bursts, or GRBs, are incredibly powerful eruptions in space, releasing as much energy as the sun will emit over its entire life. Now, these bursts often occur when massive stars collapse into black holes or when two neutron stars collide. Though rare, Hawking warned that a GRB occurring near Earth could strip away the ozone layer, exposing the planet to harmful ultraviolet radiation. This could lead to widespread damage to ecosystems and even mass extinction. While the likelihood of a GRB affecting Earth is low, the potential consequence makes it a serious concern in cosmic risk assessments. Number 8. Alien civilizations. The possibility of intelligent extraterrestrial life has captivated humanity for centuries, but Stephen Hawking had a unique and somewhat cautionary perspective on that matter. While he agreed that the discovery of alien civilizations was plausible, he warned that encountering them could be more dangerous than beneficial. Hawking suggested that advanced civilizations would likely have technology far beyond ours, which could make humans seem insignificant in their eyes. So in some cases, this could lead to exploitation of Earth's resources or even conflict, especially if humanity's actions were perceived as a threat to their specific way of life. He compared the potential discovery of aliens to the historical encounters between European explorers and indigenous populations, which often resulted in exploitation and violence. Now, given humanity's own history of colonization, Hawking feared that contact with aliens could lead to our civilization being overtaken entirely. While we might dream of peaceful exchanges with ET, Hawking's warning was rooted in the caution that such encounters might mirror the darker side of human history, where advanced societies have typically exploited those less advanced.
Sir, he doesn't have have much time.
Alright, okay, finally, tell me, what is this other threat?
Number 7. Dark matter. Dark matter is a mysterious substance making up about 85% of the universe's mass. Though it doesn't emit light or energy, its gravitational effects do shape the cosmos. Stephen Hawking believed that understanding dark matter was crucial for uncovering hidden forces that govern space-time. Its nature remains unknown, and if it's interacting with visible matter in ways we don't yet grasp, well, it could disrupt everything we know about physics. This enigma challenges our understanding of gravity, dark energy, and the future of the universe, making dark matter one of astrophysicists' greatest unsolved puzzles. Man, now I'm thinking about gravity. I'm like, what is gravity? Why are we here? What's going on?
We don't know what that is either. We call it dark energy. So if dark matter and dark energy combined make up 97% of what's going on in the universe, we have no clue what either of those are.
Number 6. Solar flares. Solar flares are bursts of energy from the sun that can disrupt Earth's technology, affecting satellites, GPS, and even power grids. Stephen Hawking warned that a strong flare could cripple modern infrastructure, cause chaos, and expose astronauts to radiation. With our reliance on space-based systems, it's crucial to monitor solar activity and prepare for these extreme events, just in case. The unpredictability of solar flares means we must remain vigilant and ready for potentially devastating impacts on communication and daily life. Yeah, that means no Wi-Fi. Can't watch this video, can't give it a thumbs up, that's for sure. That'd be a pretty lousy life, right? Number 5. Asteroids. Asteroids are of course a serious threat to Earth, with the potential to cause mass extinction similar to the event that wiped out the dinosaurs. While we have systems to track near-Earth objects, large asteroids could still go unnoticed. Stephen Hawking stressed the importance of developing technologies to prevent or even deflect such dangerous asteroids. It's giving Armageddon. Advancements in space exploration and monitoring are crucial for planetary defense, ensuring we can protect ourselves from future asteroid impacts. I mean, that would be the way to go, right? Just nice and quick, big asteroid, that's fine. I'd rather that than we melt slowly. Number 4. Cosmic strings. Cosmic strings are hypothetical defects in space-time that could have formed during the early moments of the universe. Now, these one-dimensional objects, if they do exist, they could stretch across vast distances and cause extreme gravitational disturbances. This happens in Interstellar, how cool. Hawking warned that if cosmic strings were real, they could pose a significant threat to the fabric of space-time. Their gravitational effects could tear apart galaxies, stars, and even entire solar systems. If two cosmic strings were to collide, the resulting disturbance could create a ripple effect, potentially destabilizing everything in that path. While cosmic strings remain theoretical for now and have not been directly observed yet, the possibility that they exist mean that scientists must consider their potential effects on the stability of the universe. The search for cosmic strings continues to be a fascinating yet haunting area of study, with implications for our understanding of the universe's creation and evolution going hand in hand. Number 3. Supernova. A supernova is the eruption of a massive star, releasing vast amounts of energy and matter into space. While rare, Stephen Hawking warned that if one did occur near Earth, it could have catastrophic effects. The intense radiation from a nearby supernova could alter Earth's atmosphere, increase cosmic radiation, and disrupt the magnetic field, potentially making life harder to sustain. Supernovae have been linked to past mass extinctions, and their impact could radically change Earth's environment. Hawking emphasized the importance of studying supernovas to assess potential cosmic threats. Number 2. The expanding universe. The discovery that the universe is expanding, first observed by Edwin Hubble, has reshaped our understanding of cosmology. However, at the rate of which the universe is expanding is accelerating due to a mysterious force called dark energy. Hawking proposed that if this expansion continues at an ever-increasing rate, it could eventually lead to a catastrophic event called the Big Rip. Now, in this scenario, galaxies, stars, even atoms would be stretched apart by the ever-accelerating expansion. While this event is billions of years away, thankfully, Hawking's theory painted a bleak picture for the fate of the universe, suggesting that even the fabric of space-time itself could be torn apart. Number 1. The hot end of the universe. Hawking's theory of the heat demise of the universe is one of the most chilling predictions. As the universe continues to expand, it will eventually reach a state where all matter and energy are evenly distributed. Now, this state, known as thermal equilibrium, will result in the end of the process that sustains stars and life everywhere. Stars will burn out, galaxies will drift apart, and the universe will become an eternal, dark, and lifeless place. How lovely is that? Hawking's concept of our hot end describes a universe in which no usable energy remains, rendering it incapable, of course, of supporting life. Now, this event, though billions of years away, thankfully, underscores the inevitable conclusion that the universe will one day cease to exist as we know it, leaving behind nothing but a frozen, desolate void.